Okay, so we already covered radio management, interfaces, OBM, IBM, um, antenna alignment process. What is the coarse alignment, fine adjustment? What do I need to take a look for? What do I need to actually align a proper antenna? Now we're going to cover overall installation. Okay, what does it take to do the complete install? From tower side, IF cable, grounding, how it's supposed to look.
Not like the one.
Pre-installation configuration. The following items must be completed prior to the install. First, the path analysis. In the morning, Mike Inverso gave you guys a really nice speech of how he actually does the path analysis, right? He told you path loss, what to look for, reflections, going over water, Fresnel zone, all those things. Physical site survey, a site acceptance as well. Physical site survey is when you're going to lease space on a tower, you want to make sure that it's nice AC power, constant clean power, grounding is done properly. All the grounding has a common ground on the telecom site. If you don't want multiple grounds, that's going to be really bad. Site acceptance. If you're you're gonna lease, you want the best thing because you're gonna pay for it. Typically, it's gonna be out there, American Towers, big infrastructure. If you go into a private tower on the back of a hill, on top of somebody's house, on the hospital building, make sure they have a proper grounding lugs outside and the rack space you need. Frequency coordination and frequency assigned. Triangle pre-configures the links in the factory. 0 out-of-the-box failures. As I said before, when we get your PCN, we're going to configure the link right for your specifications. Transmit power, frequency, RX and TX. But now that you know there's an A and a B side, remember, you have to send the correct side to each tower side. Okay?
B side.
Yes. If not, what's going to happen is you're going to interfere with somebody else. And that's going to wreak havoc on the tower. Frequencies, TX, power, speed are set defaults or custom specification. ATPC turned off upon shipment for the alignment process. Default output is off upon shipment, so you can actually connect the ODU. It's going to be ODU power off, but it's not going to transmit at all. Make sure to provide all current information to your sales engineer. So Ray must have all the information he needs to be able to help you build your link. Upon receivement of gear, customer should do what? Enter the approved frequencies in TX power if not pre-configured, set up the IP config on the bench for each of the links, save settings, and start installation. Again, number one thing of this training, if you remember my name, nothing, you hate me at the end of this training, remember, put it on the bench before you deploy it. Okay, that's the only thing that has to really stick to you because you don't know if the guy at UPS dropped it or on the truck it bounced around, something like that. And I didn't want to get a call, 4 o'clock, almost going home. Hey, Jose, this is some power on. I'm going to ask you one question.
Just putting it in.
Did you test it before you put it in the tower? Oh, I forgot about it. Well, I got to go home, you know that, right? Yes, so remember, put it on the bench and just power it up. Make sure you can pass traffic. Send a ping across. Make sure you do your diligence.
You might want to do that when you get it because sometimes guys will put them on the shelf for 3 months and then they take it down and then they find out, oh, we got a problem, So.
Yeah, that's the other thing. Yeah, of course, for example, also for sparing purposes. Yes. Field installation, field deployment. What do we do first? We install the antenna and the radio. There's the antenna. Big thing, big round. We put it up on the tower, we'll mount a bracket. So this is one of our mounting brackets. Of course, the bigger the antenna, the bigger the bracket. This is a little light one, and I'm super strong, so no problem. So look at the actual design of this. This can accommodate a thicker pole mount. You flip it around for a smaller pipe diameter. Now, when you do the rough alignment, you're literally going to have to move this left or right, the entire structure. One thing, a good tip is, I don't know if some mounts come with pipe clamps, so it doesn't when you loosen this, it doesn't go down on the ball itself.
Yeah.
If they don't come with it, it is a little trick, okay guys? This is not professional, but it will work. Get a little self-tapper. Just put it right here. Self-tapper on the actual pole, just so it doesn't fall down on you, right? You can stay level. Self-tapper will work fine. Then you can move it left and right. After you actually clamp it down, these are the fine-tuned adjustment bolts. There's one here.
What do you mean by a self-tapper?
Self-tapper screw.
Instead of the tower?
No, on the actual the pole, the pipe.
Oh.
Just so it doesn't slide down. Yes.
Seems
No,
like
the
you-
tower. No, forget about the tower.
It's like freak of
No.
galvanizing.
No. Just on the actual that 3-inch pipe.
Yeah.
There.
A
Just-
self-tapping screw.
Yeah.
I like that.
Yeah, just because I know that especially the small mounts, I think they don't come with pipe clamps, so that just helps you just ease of installation in general. So the fine-tune adjustment bolts here and here, azimuth, elevation, what we said before. Okay, and take it a step at a time. Just left, right first, lock it down, then do your fine-tune here. A good tip, okay? Take your time, don't strip them, right? Okay, take your time. Run the IF cable, intermediate frequency cable to the radio. Again, this is one of the most important parts, the IF cable. Okay, so when you run the IF cable, the normal bend radius, that's actually a little too much, that'll be fine. If it's a U, that's fine. You don't want to do L, 90-degree corners from this, okay? That's gonna make a really nice short on the actual MR cable. So anything, about yay, probably like that, that's fine. But you do not want to do 90-degree bend on this. This is not designed to that. Now this is designed to go 1,000 feet, so you can have your IDU well behind the actual tower with no problems for split mount systems. For the all outdoor systems, you can do from your PLE box, it's recommended 250 feet all the way to the radio. I know standard is 300 feet for Ethernet, but the longer you go, it's a PoE device. You are going to drop a little bit of power. So 200 feet, 250 feet is recommended. You can go further out, but what's going to happen? You're going to drop power, and instead of getting a gig connection, you're going to drop to 100. So 100 meg connection. So I wouldn't recommend it. Now, run the IF cable, install grounding cables. Grounding, it's a very important word in microwave, in general for the actual tower site. Install IDU on rack systems. So we put up our dish, put up the ODU, run the IF. Now we're ready to get our box, our IDU, put it on the actual rack. We power up, verify management configuration. We plug into it via the IP interface. Then we can go into it, we can read, we can manage, we can clear counters, we can do a link test, we can actually do anything on the radio.
You install ground kits and polyphasers, or just polyphasers that are grounded, or?
Well, in general, grounding, we want to talk about polyphasers at the top of the tower and before the shelter. And if the run is long enough, if it's 75 feet along the tower length. And I'm going to actually show you guys an inline grounding as well, which is what you want for the other line.
So,
yes.
On the grounding, we're not going to actually ground the antenna. We're going to ground on there's a ground on the radio.
The ODU, yes.
On the ODU, we're going to put a ground from there, and we're going to run that all the way down the tower.
No, you can actually ground it at the tower. So it's going to be literally the ODU, and then you ground your green cable, basically your thick cable, to the actual structure. That's grounded itself. So you don't have to run it all the way down, just to the grounding block there. And then there's another extra feature there, a polyphaser. So polyphaser, it's the inline protection from the ODU to the IF cable. So if it gets hit by any reason, by lightning, instead of coming down, it's a gas tube is going to blow it up and it's going to stop it. So grounding, the ODU, and a polyphaser. That's what you better want. Okay?
Polyphase is designed strictly for lightning strikes.
Yes, and it's pretty much just designed for the inline fuse, and we have two types. One goes to the ODU, one goes in the shelter, but you can always get beefier polyphasers. I mean, you can never safeguard your insulation as much. However, again, we said it before, lightning strike, no guarantees. I mean, it is what it is, right? You can have 10 polyphasers and, if it's a good strike, it's gonna blow everything out, okay? As well, you may get a lightning strike on a tower, and you may be the only one that didn't get burned, but it's, lucky shot of that. Alright, so after we do the alignment and final adjustments, validation of the link quality. There's where we're gonna look at link test, our MSC, our modulation rate. If we have a 1024 pound link, our MSCs better be pretty good to get that 1024. So I'm going to cover the antenna installation, and we said we already covered the actual antenna alignment, but this is the mount that I have here. So really quick again, you can actually have different diameter pole. If you need to do a bigger pole, you can do it like this. It's a narrow diameter pole, flip it around, get a little narrow diameter here for the bracket. And rough alignment, left to right. What we said before, little trick, self-topper on the pole, nothing major, just a little 1 inch, 2 inch self-topper, just to hold it in place because it's going to get really heavy with the antenna there. Then fine-tune adjustments on the back. We can have here this azimuth and then the actual elevation. Again, the mount is going to be proportional to the antenna. So a little, 1 footer, 2 footer, it's not a big deal. When you go to the 6 and 12, then it's going to be a really big antenna. You're not talking about fine adjustment going like this. You're going to be talking about going like this, okay? All right.
And you want a horse collar on that pipe mount.
Yeah.
You don't want a self-tapper.
Yeah, that's going to be that.
And don't take the rope off the mount that's holding it up there.
Yes, until you locked it down. Now, again, the mount can be set either left or right. The antenna itself does not have a polarity, so if by any reason you have to disassemble the antenna or the big, for example, the big antennas, 6 footers, you have to take them out of the crate and start pretty much put them together. So if you by any reason put the horizontal, up and the vertical the other way, or it doesn't really match up the way it's supposed to, it really doesn't matter. I mean, the antenna does not dictate polarity. It's a cylindrical sphere going across the waveguide. So the polarity is dictated by the actual ODU.
Oh wow.
Okay. So
the feed horn is not
the feed horn, yeah.
specific.
It's just if you look at it, it's just a cylindrical going across. There's a perfect circle. The ODU, it does have the waveguide left to vertical horizontal. Here, I'm gonna pass this around.
Propagates from there as a.
Yep. Take a look inside of it, and you'll see the actual little window. It's the vertical horizontal rectangle on the inside. Right, so moving on. Antenna installation, you first put the bracket, and then you can actually mount the antenna to the dish. We covered before the fine-tune adjustment bolts. This one here, the bottom was for the azimuths, and the top is for the elevation. Before I finish this topic here, the bigger the antenna gets, the wind load is going to be really important because you're going to need more structure to support that antenna. Because the heavier the wind load is going to happen, it's going to start to wobble, right? So you're going to put A-arm structures. It comes with a mount, so you can fix it correctly to the actual tower. This will stop the antenna, the bigger it gets, from moving around. If it moves around, you're going to see your RSSI do what? Symmetrically go up and down. Exactly. So, and it happens, right? So just make sure if it's a 4-footer, 6-footer dish, you have the right struts on the tower. All right, now we're going to get into the combiners, okay? As we said before, antenna does not have polarity. It's the actual ODU. But when you use a combiner, now the combiner has actual polarization. A combiner is used to combine two radios, two ODUs. Left and right, there's a main and there's a secondary ODU. Inside the combiner, you're going to have the waveguide orientation. It's gonna be the vertical on both sides, or it could be a orthomode combiner. Orthomode combiner is one side's V, one side's H. Standard mode combiner means both sides are the same polarity, vertical or horizontal. I have a combiner here. Where's the other one? This really cool looking combiner. So this combiner goes on the back of the antenna. Again, this is still inside of the combiner. This is an OMT, orthomode combiner. So I'm going to pass it around. Super heavy. I'm really strong. So this one side, the actual main side, it's vertical, and the other one is horizontal. Now, when you have this in the tower side, the ODU has a V going up. You put it sideways, it's horizontal. That's almost a good indication to how to mount the ODU to the combiner. But I want you to do something else. Besides looking at the V, vertical or horizontal, look first inside the combiner. Inside the combiner, the waveguide is going to be vertical, horizontal. So you're going to match that to the internal of the ODU. Okay? Instead of guiding to the V, because it gets confusing sometimes. And I had this a couple times happen to customers. They cross-polarize all four. They get a good RSSI, but nothing locks. Okay? So this happens quite a bit in the field. I'm going to pass it around. And again, remember, rule of thumb. When I'm using a combiner, make sure the ODU matches the internal polarization of the combiner.
Like a slit like this, make your other slit like
Correct. Plain and simple.
Do you, and you always, this is basic though, you always want to leave that plastic on?
No, this thing I take it off.
So at the time of installation, you
Yes.
do want that
Yeah,
to come off.
you're going to have
We've
this as
taken
clean
them
as
off.
possible. Yeah. Clean as possible. So I'm going to pass this around. Now, one thing also, this one is really nice. Has a level on the back.
Oh.
If that level is not perfectly aligned, leveled out, if it's like that, you may have cross pole without even knowing it. So you have to get this level perfectly. That's what that bubble is there. Okay? Again, also, seating this on the back of the antenna, if this is not well seated on the back of the antenna, mounted properly, your MAC is going to degrade dramatically. So when you put this on the back of the antenna, make sure the seals, the gaskets, everything's in here, it's properly sealed. I don't mean ratchet down all the way until you crack it. No, just make sure it actually seats properly there. Okay.
So if we had link,
Hmm?
and then we inserted that combiner, how much loss would that combiner add that would we be able to measure any loss on that combiner?
0.5
Right.
dB per side.
Per side, yeah.
Very minimal.
Okay, so really, so if we had a